Welcome to Web Handling. My name is Dave Roisum. In this clip, we look at a seemingly impossible troubleshooting case history that involves 4 machines in 4 states scattered across 2 countries. Our final exam will be to troubleshoot this problem. Due to the complexity, you may wish to pause this video at each slide to think about what has been learned and what you would try next. The complaint is wrinkling on a press that takes dozens of sheets and compresses them into flooring. The problem has been chronic, which, as we saw in an earlier clip, means that it has been present for some time. Though it comes and goes, all problems do this, and this is generally not a very useful observation, as my problem-solving students have learned. In this case, the problem was first observed perhaps 30 years ago. Our challenge is to troubleshoot this in a single day, and to be so solid with the analysis that all parties will agree to the conclusions. Upon closer inspection, the problem seems to be truly daunting. There are hundreds of forming and converting components scattered across 2 countries. Where do we even start? A general rule for any problem solving is to always start at the customer. Find out what the problem really is, rather than relying on what they say it is, or even worse yet, what the customer service rep says they say it is. The customer complains that some sheets don't lay flat in the press and that this can cause hard wrinkles. As you should know, Layflat is an alias for bagginess, so perhaps we have a baggy web. Trying to smash something flat that isn't flat to start with could very well cause wrinkling. A vital observation not offered by the customer, because they don't often think of shapes, is that the sheets, when puckered, have a characteristic pattern as seen here. Note that this pattern is subtle, so you need to look good with side lighting and to look carefully. Now that we have a very firm picture of the trouble at the end-use customer, it is time to move upstream in the process. What we observe is that the sheets leaving Quebec have an identical pattern. That means that theories offered by various people with regard to aging and transportation can probably be dismissed. The Quebec Coater is a paper unwind, followed by a coater, followed by an airflow dryer, and finally a sheeter. We walk the line. What was observed was a profoundly baggy center exiting the dryer, while upstream the web appeared to be flat. Curiously, or not, if you are familiar with problem solving, the Quebecois did not notice the bagginess, because the web always looked like that. Does that mean that the sheeter is acquitted? Does that mean the dryer is at fault? Please pause the video and think about this for a bit. The sheeter is not as likely because it merely cross-cuts the web and thus is not likely to make a baggy center. However, we cannot make any conclusions about the dryer being a problem or not being a problem. Just because the web appears flat going in means nothing. As my Web 101 students learn, there could very well be invisible profile flaw in the web upstream of the dryer. Sometime in the process, we need to construct a working theory. Perhaps now is the time. Our working theory is that tight edges at the dryer exit is causing lay-flat problems on the sheets that sometimes wrinkle when you try and press them flat. In the next slide, we will be super careful about the tight edges conclusion. First, we restate our observation that tight edges at the dryer exit are compatible with a baggy center. Next, we do a strip test, as my Web 101 students learned how. The strip test verifies and quantifies the tight edges. The width of the defect is about 4 inches, and the severity is several parts per thousand. Also compatible with tight edges is the camber observed when the edges are cut loose. Camber is a specific form of bagginess. We also note that when an edge is cut off, half of the web is cleared of the lay-flat problem. This again illustrates that the defect really is the outer 4 inches. Tight edges cause a cinching or stitching of the web as the extra length of the center is taken by the extra out-of-plane path length. My Web 101 students will recall that this intimate tension versus length connection is what mechanics people call stresses and strains. Finally, we observe that the diagonal wrinkles at the corners of the sheet are caused because the cross-cutting allows the tight edges to retract. For those keeping score, we have now explained all aspects of every characteristic feature of the wrinkling pattern. In summary, we are as darn sure as it ever gets in the real world that the edges are tight, leaving the dryer. Why are we so careful about this analysis? It is because there are 3 companies involved, and we need to convince all, particularly the culpable party, that they are the root cause of the trouble and they need to do something different. Only problem is, however, that we have yet to identify the component, much less the culpable party. The salient question here and now is, who owns the frown shape? However, before we answer that, we must pick a place to begin the next step of our investigation. Pause the tape if you wish to think about this a bit. My Web 101 students already know the answers to these questions. The rest of you may wish to pause the tape and think about what traits are most important for effective problem solving. Perhaps surprisingly, traits that are most useful for good problem solving are not intelligent, and certainly not experience. The traits most useful are laziness and creativity. Since laziness is an important trait, the place to work next may be right where you are at this moment. The what next is to try and find a simple test that will divide the solution space roughly in half. This technique is taught in my problem-solving schools and books. The question is, what simple test would this be? Pause the tape and think about this. How we did this in the real world was to go to lunch. Over lunch, a senior operator came up with the simple test. Can you figure out what that might be? We slid off one edge of the supply roll on a rewinder and sent it down through the middle of the coater dryer. If the shape was owned by the paper, slitting off an edge would result in an asymmetric problem. If the problem was unchanged, the shape was owned by the coater dryer. Those who have taken my problem-solving courses know that it is often better to do your experiment on one side rather than on both sides of the web. The result of trimming off one edge prior to running through the coater dryer was that the sheet looked about as unflat as it always had. It also had the same pattern. So now the question is whether the coater or the dryer owns the edges. However, the more immediate question is, where and how do we do the test? Pause the tape and give this some thought. Recall that the number one trait of a good problem solver is laziness. So which is easier to bend the shape of, a coater or a dryer? The answer is usually a coater. It is easy on many coaters to increase the coat weight on one side. If we had a gravure coater, on the other hand, we may have wished to work on the dryer instead by baffling or some other approach. The question is now, how much do we move the coater, or the dryer as may be the case? At this point, we might need a bit of process knowledge. I first might ask QA or the process engineer how much the coat weight varies on its own accord. I would like to do an experiment that varied the side-to-side coat weight 2 to 10 times that much, if I could. So next, we ask the operator, how much do you think we could move the coater without breaking the machine or breaking the web down? He might first reply that if we move more than X, we would be out of spec. If so, we need to restate the question and insist that we want to be out of spec as much as possible without breaking down. The results of the violent bias of coat weight is that the sheets were as puckered as much as usual and, more importantly, had the same pucker pattern. Our conclusion is that the shape is not owned by the coater and hence, by process of elimination, must be the dryer. At this point, the web handler can only offer the possibilities that the frown-shaped edge effects are either owned by the mere presence of an edge or by the dryer. At this point, we may turn the last step over to dryer experts now that we have pinpointed not only the machine, but the part of the machine where the bagginess was created. This problem at first looks dauntingly difficult. However, since we don't often get to pick the problems we work on, we must soldier on. What we have learned and reinforced with this example problem is that Baggy web troubleshooting almost always involves the same approaches. Recognize shapes, try to bend shapes, and so on. As problems get more complicated, we need to be even more methodical and disciplined. As problems get more costly, we must be even more careful in verifying our analysis. Thank you so very much for watching this module in my Plant Practical video series. While you have now graduated from my Baggy Web short course series, we have a couple of postgraduate clips to follow. These will deal with the unique challenges of certain web materials, as well as to give you a few more tips for problem solving. Stay tuned.